All right, so keeping track of my lectures here, the thing that I'm doing is listing all the lectures on the side here, and then I put down the date at the bottom. You can't see it's down here. There's the date. Today being the 15th, and the 14th. So I've only done a little bit of studying so far today. I haven't reviewed very much. But I'm going on the list here and reviewing different lectures, and I think I'm going to talk about, the one I'm going to do here is going to be lecture 10. I learned by talking, and so this is helpful for me. This is on trauma, malformations lecture. So I'm going to pull the study guide I have for that. The way that we divided up my group is that someone prepared something for this particular lecture. I happen to do this particular one. This is one of my study guides that I put together, but I have other people doing other ones. And so what lecture number was that? It was lecture 10. So I have it listed here. Here it is. So I'm going to go ahead and pull up my study guide for this lecture. That's not the study guide. Here's the study guide. And kind of talk my way through it. And I've got a lot of pictures at the end here that you can just Google these online, because they're should all be online. But first, before I go into the lecture, I want to give some really basic overview of different types of tumors and things to know about them. So to start off with here, this is from my previous lecture that I did. Start off here, let's go ahead and talk about the adult primary brain tumors. The first one we want to talk about is a glioblastoma. Okay, so glioblastoma. Okay, glioblastoma multiforme is a lot of times they call this at the end, but we'll just stick with glioblastoma. It's a grade 4 astrocytoma. So if you remember what astrocytes are these cells in the brain. You know, they help with potassium metabolism, and they're kind of like the little cleanup cells. They do a lot of things. They help with the blood-brain barrier, useful cells. But this glioblastoma is the most common primary brain tumor. Now, I say primary brain tumor. What I mean here is there are brain tumors that originate in the brain. In other words, they came from one of these cells in the brain, and they grew in the brain. And there are also types of tumors that came from some other location, like let's say like the lungs or something. And these are called metastatic cancers, and they started here, and a little piece, some of the cells broke off, and they traveled through the bloodstream, and they went here, and then they end up metastasizing here in the brain. Okay, so metastatic cancers are the most common cancers overall, which are found in the brain, but they're not primary cancers of the brain. Okay, so when I say that glioblastoma is the most common primary cancer of the brain, it means that it's the most common cancer that originated in the brain, didn't metastasize from somewhere else. Okay, follow that? Hopefully. If not, look it up. So let's talk a little bit about this glioblastoma. Glioblastoma, I should probably just Google a picture for you so you can see what they look like. Even though you can do this, but I'll save you the trouble. Glioblastoma. Here are some pictures. What they look like. It's not gonna hear images. Okay, here's some pictures. Now, one of the things you'll see with this, is this a good picture of glioblastoma? There we go. All right. Here's a glioblastoma multiforme. Okay, see that big nasty thing here? It has about a 1-year median survival, so people don't last very long. They get this one, that's not going to be very good for them. Let me go ahead and take a little screenshot of this, and I'll throw it on the picture when I'm talking about it, so we can kind of put it all in here. So here you go. There's a better picture of it. 1-year median survival. These people are going to have. It says it's found in the cerebral hemispheres. See, so here's the cerebrum here. Here's the cerebrum here. So this is one of the hemispheres. That's sure enough, it's found in the cerebral hemisphere. And says that it can cross the corpus callosum. Okay, so in brains there is a structure called the corpus callosum, and it's kind of like this middle thing here, whatever. And these types of tumors can actually cross. Doesn't happen very often, but sometimes it can happen. So they call that a butterfly glioma sometimes. So the stain stain the astrocytes for GFAP. So earlier I mentioned a little bit about astrocytes. Astrocytes have this specific aspect of them that can be stained, GFAP. So since this is an astrocyte tumor, remember glioblastoma it's a grade 4 astrocytoma, you can stain for GFAP and this will show up, okay? Because it comes from astrocytes. The histology is called pseudopalisading. Pseudopalisading, I should probably type in that in Google to show you a good picture. Pseudopalisading, there it is. Probably add on with a glioblastoma. There we go. So this will show you a good histological image of pseudopalisading, what it looks like. But it's almost like you're building a little, there you go. Somebody already labeled it for us. So here's the area of necrosis, and then around the edge you get this almost like it's building up a little palisade or a wall or palace around it, right? So this pseudopalisading, they call it pseudopalisading because I think normal palisading occurs around blood vessels, I believe. I don't remember, to be honest with you. So that's that pseudopalisading going on there. Good image of that. So let's keep talking about this now. Some other things worthy of note with these guys is that they are pleomorphic tumor cells. So pleomorphic, I believe that means that they can have many different shapes and sizes and whatnot. They're all not round or flat or square. There's all kinds of sizes, and they border the central areas of necrosis and hemorrhage. Okay, so they get these pleomorphic cells that are bordering the area of necrosis. So in here, whatever. Keep choosing 4 colors. There we go. Okay, so that was the first type of tumor. That's called a glioblastoma. Now let's talk about the second type here, which is a meningioma. Okay, hopefully when I say meningioma, you recognize a word in here, and that's meninges. Okay, so meninges is one of those covering in the brains, and this is a cancer of meninges. So this is actually the #1 benign brain tumor. Now, when I use the word benign, that means that it's not going to kill you, probably. Okay, it's not like a metastatic type, or not metastatic. Yeah, it's not gonna cause any major problems. It's a benign tumor, but it's not good. You want to get him out of there, probably. Maybe, I don't know. I'm not sure. Depends. Talk to the neurosurgeon. They'll know. So here's this meningioma. I guess I could Google an image so you can see what they look like. Meningioma. Okay. So images, here we go. Find a good looking meningioma. Okay, there's a good one. So the person lifted up the dura here, and you can see underneath there's that meningioma. Now, one thing you'll notice about this particular type of tumor is that it has a extracranial location. Oops, where am I here? Extraaxial is the word they use for that. So earlier, the other tumor we saw was kind of inside one of those hemispheres. It was in here. This one, look at how it's on the outside. Why is that? Well, this is the meninges, surrounding the brain, dura, pia, arachnoid matter, whatever, and it's a tumor of that. And so it does push down on the brain, which is bad. If it gets too big, it can really cause some problems. But you can see it's outside of the brain, which makes it a little bit better than something that's benign. So there's your meningioma. Most often occurs in the convexities of the hemispheres, okay? And it's near the surface of the brain and the parasagittal region. Arises from arachnoid cells. Okay, remember there's a subarachnoid area there. The arachnoid is one of those layers of the meninges. It is extraaxial. I already mentioned that, hopefully. Did I say intraaxial? It's extraaxial. Hopefully I didn't say that word wrong earlier. External to the brain parenchyma, and may have dura attachment, like this one. See, this one's attached to the dura. Let's see, right there. Right there, it's attached to the dura. It is often asymptomatic, may present with seizures or focal neurological signs. And that would just be if it was pressing on some area where it would cause a neurological sign. I don't know, maybe it's pressing on Broca's area, or I don't know, whatever thing it's pressing on. What do you do with these guys? Well, you're going to take them out, or you could do some radiosurgery to try to kill it. Histology, you're going to see spindle cells. I'm going to go ahead and type in meningioma. Actually, they probably should show. Here we go. Yep, and that's a micrograph of a meningioma. Let's take a little picture here and then describe it. So this guy here, this meningioma, it has, the description here is spindle cells concentrically arranged in a whorled pattern. So I think what they're talking about here is this kind of seems like this kind of whorl, it's like, oh, it looks all swirly in here. I don't know, I'm seeing all this like kind of swirly lines, and that must be what they're talking about, is these spindle cells arranged in this whorled pattern. And also it mentions Schwannoma bodies, which are laminated calcifications. So let's see some Schwannoma bodies. Now you can Google that one, look up exactly what that looks like. But so those are some things that you can notice with the meningioma. All right, so let's move on to the next type of tumor here. Next is a Schwannoma. Now, when you see the word Schwannoma, you should probably thinking of Schwann cells. Remember, in the peripheral nervous system, we have these cells called Schwann cells, and they wrap around the axons of the neurons, and they create this myelin sheath. And this myelin sheath, it helps the signal transduction to be sped up, and also has some other good functions as well. PNS, it's Schwann cells. If it's in the CNS, then it's going to be oligodendrocytes. And oligodendrocytes are similar to the Schwann cells, except for they have these foot processes and they attach onto many axons. So it's a little different there. Okay, very good. So these Schwannomas are classically, maybe I should find a picture for you so that we can see what we're talking about. SCH1, oops, Schwannoma, there it is. Okay, so here's a picture of a Schwannoma as soon as I get to the images section, and I'll throw it in our picture there. All right, well, I don't see any good picture that I like really. All right, apparently that's a histological examination of Schwannoma, so let's snag it. What I wanted to see was a gross picture of a Schwannoma, but I don't know if they're going to give me one of those. That's a trigeminal Schwannoma. So remember the trigeminal nerve? Okay. All right, that's like a radiograph or whatever. What I wanted though was a gross picture. A Schwannoma. Okay, so that must be a Schwannoma there. The myelin just got crazy in this guy's arm. Okay, so there you go, Schwannoma. Yummy. Okay, so moving on. Sorry, you got some pictures now, so you can attach your knowledge to something. All right, Schwannoma. Classically at the cerebellopontine angle. Okay, so the cerebellopontine angle is, I'm seeing two words in there. I'm going to write this out. Cerebellopontine. And if you look at a brain, let's go ahead and pull up a brain stem. That'll probably be a good way to get the picture I'm looking for here. Sure, this one will probably work. Okay, so so here this is a cut of a brain, and on the brain you've got different parts. We have the cerebellum back here, and then we've got the pons right there. So when this says cerebellopontine junction, I'm imagining it's like right there, most likely. Okay, so cerebellopontine junction, and it says, but it can be along any peripheral nerve, as we're seeing over here. What's going on? Schwann cell origin, it says S100 positive. I don't even know what that is, to be honest with you. It says often localized to cranial nerve 8. Okay, so cranial nerve 8, remember what nerve that is? That's the vestibulocochlear nerve. So they always do these with the Roman numerals, which is really just not cool. But but there it is, vestibulocochlear nerve. So that could disrupt that, and they call those vestibular schwannomas. And it is resectable or treated with stereotactic radiosurgery. And bilateral vestibular schwannomas are found in NF2, whatever the heck that is. All right, whatever. Moving on. Next type of tumor here is an oligodendroglioma. And I talked about these earlier. Oligodendroglioma. We talked about the schwannoma. That was in the peripheral nervous system kind of stuff, or on tracks, whatever. But this one is specifically in the CNS. This is like within the brain parenchyma type stuff. These are really rare. They go really slow. Usually they're in the frontal lobes. That makes sense. A lot of connections in the frontal lobes. They call them chicken wire capillary pattern. Let's go ahead and click on one of these, or look at one. Oligodendroglioma. See what they look like. So there's a good picture. There it is in the frontal lobe, just like they mentioned. So I'll snag that picture. That's a good one. And they also mentioned that they are. This is a good. There are a lot of good pictures here of these guys. So one thing that my teacher said that was a nice way to identify these things was that the way she differentiates these from like an astrocytoma or something like that is she says that the nuclei of these cells are round. Oh, man, I keep doing that. They're round, okay? Look at all these nuclei. They're all round nuclei. So round looks like an O. O looks like oligo, okay? Oligodendroglioma. So that's a good way to recognize. You see this histological examination should be kind of a giveaway as compared to some of the other images we looked at earlier where they're not so round and pretty. More information about oligodendrogliomas is that they call these the fried egg cells, okay? So if you look at this, let's say it's just this guy here, it's going to have this thing here. It almost looks like that's the yellow part, and this almost looks like the white part, so it looks like a fried egg appearance with a round nuclei with clear cytoplasm, often calcified in oligodendroglioma. All right, last one of mention for this part of the adult primary brain tumors is going to be the pituitary adenoma. Man, I did it again. Pituitary adenoma. So for the pituitary adenoma, this is most commonly prolactinoma. I'm going to Google that one because I don't really. Prolactin seems like prolactinoma. Probably high levels of prolactin is what I'm guessing. I think prolactin is what causes. Yeah, here's a good example here of what's going on here. So prolactinoma, someone's producing lots of milk, or maybe they're having mast, can't remember the word, but enlargement, whatever, that's what's going on there. So that's a good example. Prolactinoma. What do you have here? Bitemporal hemianopia. Now this is kind of a cool thing, and I'm going to pull up the circle of Willis with this one. What's a better way to get this? Probably, well, this picture illustrates it pretty well, actually. But I want to find a better picture for exactly what I'm looking for here. But it's kind of it's where it's situated in the brain, specifically. Here we go. There we go. This is a great picture. Okay, so if you look at this picture, what you see here is the circle of Willis, where it's located. It surrounds this. Well, you know what? I'm going to use that one, but I'm also going to use another one. Here we go. Oh, yeah, this is beautiful. This is a wonderful picture here. Okay, so this is an explanation about the bitemporal that word that I said earlier. Here we go. All kinds of pictures to explain this thing. So this one has bitemporal hemianopia. Okay, so what's going on with bitemporal hemianopia? Essentially, you've got your pituitary, your pituitary is sitting like right in there, okay? So if pituitary is sitting right in there, and a person has a pituitary adenoma, okay, that means that this little area right here, and look here at this optic tract, look at this. So this is where the tumor is, and what's that going to do? Well, look at this middle part right here, the optic tract. It's going to mess up your vision. They call this bitemporal hemianopia. This is kind of showing almost like where the lens, where it's coming from. So let's follow this through and see where this goes. We get light coming from the lateral region, striking the inner region through the lens of the eye, the inner part of the retina, travels down right there, okay? So that is going to mess up. So if we were to draw two eyes here, that's going to be messing up this eye's lateral field. And then let's track over here and follow this up, and we see that this light from this region over here comes in, strikes the inner part of this eye, okay, and that travels down. That's right in the middle there on the optic chiasm. It's going to mess up this outer part. So what do we have here is this person has this kind of lateral gaze, both eyes, bitemporal hemianopia. Hemianopia. Anyway, that's if I'm understanding this correctly. Hopefully I didn't really just mess that up and explain something totally wrong. But either way, hopefully that was a helpful review where you can either just say, hey, you're messed up, and correct me, and it'll be a good review for you. If not, then hopefully that was correct and helpful. So it's due to pressure on the optic chiasm, which is what I was showing there, which is right in the middle. And yeah, so that concludes our discussion of adult primary brain tumors. I hope you enjoyed it, and stay tuned for the next one, which is going to be childhood primary brain tumors.